Montreal, Canada has significant volcanic activity, or at least it once did very long ago. Specifically, 125 million years ago when the landscape looked less like this and more like this. Flying reptiles known as pterosaurs and large dinosaurs roamed the densely forested and fairly flat lush green landscape. However, steam would be rising from isolated patches of unusually bright blue-colored acidic hot springs, and suddenly you would feel yet another earthquake, which were all too common here in the early Cretaceous period. Fast forward to the present, and this ancient magmatic activity left behind a series of 10 fairly closely spaced raised mountains, one of which is just west of downtown Montreal, with these being known as the Monteregian Hills. Despite their appearance, these are not technically volcanoes, which is a common misconception, by the way. For something to be considered a volcano, magma or eruptive products of a phreatic nature must have erupted onto the surface. We have found no conclusive evidence that this ever occurred, meaning that these mountains were simply shallow to intermediate depth massive bodies of magma that fully solidified long ago. However, their emplacement was, in my opinion, likely associated with abundant earthquakes caused by magma movement, surface ground deformation, and surface geothermal features such as hot springs and maybe even geysers appearing. However, what makes these mountains so distinctively fascinating all comes down to the fact that they form an easy-to-see chain of activity where vents to the east get progressively younger, just like in the Hawaiian island chain, as these ancient intrusions represent something so much larger. A chain of explosion craters, mountains, volcanoes, and igneous intrusions that span a whopping 7,000 kilometers from Nunavut to Ontario, Quebec, Vermont, New Hampshire, and a wide swath of the Atlantic Ocean, with all of these vents being emplaced across 215 million years. Today, this mantle plume known as the Great Meteor Hotspot may no longer be active, but it still seemingly exists at a spot 1,800 kilometers west of Morocco's coastline. The Monteregian Hills merely represent a negligible portion of this province, with all 10 relevant vents forming in a narrow stretch of time between 125 and 123 million years ago. Each of these structures formed in essentially the same manner, albeit with minor variations between them. Since the underlying hotspot was about 200 degrees Celsius hotter than the surrounding upper mantle material, it was less dense and naturally rose, causing large volumes of magma to intermittently intrude into the lower crust. However, because this mantle plume pulled material from lower sections of the mantle as well, the magmas that resulted from it had a wide range of compositions, although all were extremely alkali element rich. The heat from the rising magma as it rose began baking adjacent sedimentary rock layers, turning them into hornfills via what is known as contact metamorphism. Eventually, each magma intrusion would reach a spot between 2 and 7 kilometers depth, where, probably due to the fact it didn't contain enough volatiles or gas to continue the progression upwards, its motion stopped. It then pulled in volume until eventually the magma supply ended, causing the large plutons to eventually fully solidify. More than 100 million years of erosion followed, and during that time span, the softer overlying and adjacent sedimentary and metamorphic rock was eroded away, while the more resistant to erosion igneous rock remained. This is why they today rise from the ground despite having once been buried thousands of meters underground. These exposed plutons contain large volumes of carbonatite, pyroxenite, and syenite among other similar rock types. Altogether, these plutons contain an absurdly wide range of distinct minerals, more than 500 in fact. Many of the more exotic minerals can be linked to the Oka carbonatite complex via compounds associated with the element niobium, tantalum, and/or cerium. The Oka complex for a time contained one of the largest niobium mines in the world before it ceased operations. There is also Mount St. Hilaire, which itself contains more than 400 distinct minerals, marking it as one of the world's most diverse mineral localities in terms of the sheer number of overall minerals present there. So, as you look at the modern Monteregian Hills today, remember the hotspot they were associated with and how deep these igneous bodies once were. As a final note, I would like to thank my new YouTube channel member Astrid Mollungberg for supporting my work.